Good day, ladies and gentlemen, and once again we are back together and just looking at statistics this time around. So if you haven't subscribed, please just make sure that you're part of the family, and please just continue to recommend, our YouTube channel to as many people as possible. We want to get to 100,000, and not just for the sake of numbers, but for the sake of impact. Want to make sure that as many people are aware of this channel and they are assisted in terms of their mathematics and physics. Okay, so by the way, I consider stats to be one of those very practical sections in mathematics. You're going to use that probably throughout most of your life if you're going to be doing anything that's related to maths. So let's jump right into the lesson, and I hope that you enjoy it. All right, let's get into our lesson. So when we talk about statistics, first of all, just remember that statistics is one of the most useful sections in mathematics. In fact, I'd say of all the sections that you go through in mathematics, probably this is one of amongst the widest, the most widely used sections in mathematics. And what we're doing here is that we are taking large groups of data, but we're taking a smaller sample to try and make a conclusion around big, sample sizes, or rather big data groups. It can be human beings, or it can be whatever form of data that we have. Now, what we do is we use what we call measures of central tendency. All right, so these are measures of central tendency. Okay, and what these measures do is that they help us, whether it is group data or ungrouped data, you are going to actually use that to sort of draw a comparative study around each of the data sets that you have. Now, let's talk about these measures of central tendency that we often use. All right, the first one is what we call the mean. All right, so when we talk about the mean, okay, so if you are given a set of data, and by the way, I'm going to illustrate this with examples. When we talk about the mean, we often use the symbol x bar, right? And how we simply calculate the mean is that we're going to take the sum of all your data, right? And you are going to divide it, so sum of all your data, and you are going to divide it by the number of data sets that you have, okay? So the number of values that you have, so you take all of those values. So say for argument's sake, you had the age of 10 children. The other one is 5, the other one is 6, and the other one is say 9, and the other 3 are 10 years old. So you're going to take all of those and sum them up and divide it by the number of children that you took ages from. So that is what we call the mean. All right, I'm going to illustrate it very well how we are going to use that. And then secondly, we've got what we call the median. Okay, you can call this triple M because it's mean, median, and the other one is mode, but we're going to talk about the mode just now. Right, so the second one is what we call the median. The median. Now, what the median is, this is the middlemost value. And by the way, I'm going to talk about that a little bit later as well. So this is the middlemost value. All right, now, by the way, obtaining the median can be different whether your data set is even or odd. So when you've got an even data set, okay, so for an even data set, what you'd normally find is that to find your median, you'll take the two middlemost values, you will add them up. Okay, so let's say you find your two middle values, and then you're going to add them up. Let's say we had 10 data sets, the age of children or whatever the case is. So what you're going to do is I'm going to take x6 plus x5 plus x6, right? So in this case it means I'm going to take the fifth and the sixth value, because those are the ones that are right in the middle, and I'm going to divide that by 2 to get the median. But if you've got an odd data set, okay, so if my data set is odd, then all I'm going to do is just find the middlemost value, and it will just simply be, so if I've got let's say 9 9 data sets. In this case, what I'm going to do is I'm just simply going to take the 5th one, because what it does is that it divides my data into 2 parts, right? So in this case, if I had 9, I would simply take x5 in that case, because then I would have 4 on the one side and I'd have 4 on the other, right? So it depends on whether my data is odd or even, all right? And then, and by the way, please don't worry too much. I'm going to actually explain all of this as we do some examples together. Right, and then the last one in terms of the measures of central tendency, right? So we talk about the mode, or, they can even call it the modal value, right? So what the mode is, it's the most common. So that's the most common of the values that you have, right? So say, for argument's sake, you are taking the age of children who visit an ice cream truck, all right? So what you're going to do is you find that maybe of the 10 children that visited, 4 of them were 7 years old. So what does that mean? It means that in that case, the most common number that is appearing is the number 7. So that would be your mode in that case. Okay, so it is that number that appears the most, right? Now, we're going to talk about the box and whisker plot in just a few. So these, as I said, this is what we call are measures of central tendency, and as a result, they inform how our data is set. Okay, right. And I want to actually illustrate this. I want to take as much time illustrating this through an example. I think nothing makes our point more clearer, than taking an example. All right. Now, in this case, when we are drawing a box and whisker plot, right? So the values, now let's talk about box and whisker, right? And in this case, we're no longer talking about just the measures of central tendency. We are now referring, or rather talking about the box and whisker plot, right? So there are values that we are going to be looking for, all right? And the first value that we always look for, okay, so this is the box and whisker plot, okay? And in this case, the value that we always look for first, okay, maybe let me just track back a little bit, right? This thing is misbehaving, right? So the first thing that you're always going to do is please make sure that you order your data in ascending order, right? So order your data in ascending order, right? So what does that mean? You take from the smallest number right up to the highest number as they increase in that particular order, right? So so we're going to look for value number 1. That would be your minimum value. Minimum. Oh gosh, what happens to my spelling, right? Minimum. Look at me. So I go for my minimum value, right? Minimum value. And in this case, of course, we're going to look for, so we find the maximum value. So those are the, so maximum, okay. So those are the 2 values that we, first of all, of course, we're going to look at those. And then we're going to look for, obviously, the other values, right? Now, in this case, we did say the other values that I'm going to look for is my mean, okay? So remember how we said we look for the mean. We said in this case, we are going to look at, no, actually not the mean, rather the median. Sorry about that. So the median, so I'm going to look for the median in that case, right? And then what I simply do, once I've found these three values, I'm also now going to look for, right? We call it Q1. Okay. Now what Q1 is that, now remember what the median does. It will divide your data into two sets, right? It divides your data in half. But what you then do is that if you've got the first half, you will find the half of your first half. So in that case, we call that Q1, right? So in that case, we look for Q1, and in Q1, basically, it's the first quarter of your data. We call this lower quartile, right? So we call that quartile 1. And look at that word quartile. There's quarter there. So in that case, we call that quartile 1. Okay, so that's Q1. As I said, I'm going to illustrate all of this. Right. And then you are going to also look for Q3 in that case. By the way, let me just simply refer to this. Remember that what this will be, this is what we call quartile 2 in this case, which is your median. Okay. Right, as I did say that it the value divides your data into halves, right? So in this case, you've got Q3, which is quartile 3. Okay. And in this case, what it simply does is it divides your upper quartile, or your second half of your data, right, into another half, right? So in this case, you've got all of those values. Essentially, ladies and gents, when you've got your box and whisker plot, right? So what you're going to do is you're just going to make sure that you draw a number line, okay? And what you simply do is you're going to make sure that you draw your number line according to scale, all right? Right, so you're going to identify, let's say, your minimum value, all right? So say, for argument's sake, that's our minimum value, whatever that value is. You identify your maximum value, right? And then you're going to take quartile 1. Say, maybe let's say quartile 1 is over there. Okay, and let's look for, let's say, for argument's sake, quartile 2. Okay, and there's your quartile 2 over there. And what we then do is we're going to just make sure that we draw, in that case, let's just say, for argument's sake, there's our median over there. All right, so that's quartile 2. That would be quartile, So that's our minimum value. We said that's our maximum value. And this is our lower quartile. That would be quartile 1. This would be quartile 3. Sorry about that. I said quartile 2. So that's quartile 3. Let's just say, for argument's sake, our median is over there. And what we simply do is we are going to draw our whiskers and, draw a conclusion about that. Okay, right. So what I want us to do, ladies and gents, is rather, we can talk about this all day. Let's talk about, in this case, let's have a data set, and then, let's make sure that we draw a conclusion, know how to apply this. Just before we go to a data set, okay, just the last thing that I want you guys to note. So when we draw a box and whisker plot, before I get into the example, there's certain information that we actually need, right? Because what it does is that it helps us to make a conclusion, right? Sometimes you can find a box and whisker plot that looks, to some extent, something like this. All right, I know this is a very rough sketch. Now, more or less, these look kind of equal and symmetrical. And what this simply means about this data set is that for this set of data, it looks perfectly symmetrical. Okay, so it means that in this case your data is evenly distributed. Okay, so your data is evenly distributed, and so in this case you've got two equal halves. So that means that your mean, your mode, your median are more or less around the same point, right? Now, what we simply say, ladies and gents, and please, I want you to note this. In order for us to measure, okay, symmetry, what we do is we will take the mean and we will subtract it from the median. Okay, so we take the mean. Remember, we said when we calculate the mean, all we simply do is to sum all your data, you subtract your median, and in that case, when your mean minus your median gives you 0, okay, then we can draw the conclusion that we've got data that is symmetrical. Okay, so it means it is not skewed data. All right, because remember, in this case, I'll tell you what the skewness actually tells us. All right, but in this case, let's just say you have a box and whisker plot that looks more or less something like this. Let's say there is our Q2 over there. All right, and then you've got something that looks like this. Now, I want you to please note, when you have this kind of data set, what this simply implies is that your data is more spread to the right. Can you see that you've got a longer whisker towards the right hand side? So it means that your data is more spread to the right, okay, than it is to the left hand side. Okay, so in this case, we say in this particular case that this data set is positively skewed. If you think about it, we said it is more spread to the right. So the right, usually in your Cartesian plane, your right is more your positive side. So we say this is positively skewed data. Okay, so this is positively skewed. Now, what does that mean? So it means that if we take the mean minus the median, okay, and we get a value that is greater than 0, so we get a positive value, right? Then we know that our data set is positively skewed, or you can even say it is skewed to the right, okay? Right, so it means that the median, okay, is more nearer rather to the start than it is to the end of your data set. Okay, I hope that makes sense, ladies and gents. As I said, so this is when we are measuring how the data is distributed relative to the mean. Right, now, and then the last one, of course, you can have a situation where you've got let's say in our box and whisker plot, okay, there it is over there, and you end up with data that looks more or less like this. Okay, so there's your median once again. Okay, but what do you notice this time around? Okay, there is a longer whisker more towards the left. Okay, so what does that mean? It means that your data is spread more to the left than it is to the right. Okay, so what this simply means, again, so we say that this is negatively skewed. Okay, so it is negatively skewed data. Okay, oh, by the way, I didn't show you the distribution for the second one. Okay, so in this particular case, I want you to please note, so when we say it is positively skewed, so you'd find that in this particular case, right, so let me just, okay, yeah, I'm not sure if I'm illustrating it quite nicely. In this case, it means that you've got your mean is more towards the left hand side. Okay, so it means that your data in this case is more spread towards the right. So you've got something that looks like that. And then for negatively skewed data, ladies and gents, what we've got is that if we find that our mean minus our median, okay, is less than 0, so we say that it is negatively skewed, okay, or you can say it is skewed to the left, okay. So you can say it is skewed to the left. All right. And in this case, what this means is that the mean is more towards the end. Okay. And in that case, when we draw the distribution of it, you'd find that you've got something that looks more or less like that. Okay. Where there's your mean more towards this side, and that is what it looks like. Okay, right, ladies and gents, let me just not bombard you with a lot of talk. Let's just go into an example. All right, so for our very first example, they say the following data records the math marks of 10 learners in a class. Okay, and there's our data there. We've got 60, 43, that one got 70. This is quite a relatively bright class. Okay, so the other 85 and so on and so forth. Right, so they want us to do the following to determine the mean, the median, and the mode. The range, we haven't talked about the range just yet, but we're going to talk about it. Okay, and the interquartile range, and I'm going to talk about those a little bit later on, just to comment on what their use is. And finally, they want us to draw the box and whisker plot and to determine the skewness of the data. Now, ladies and gents, what I've done is I've already grouped this data in ascending order. All right, I've already done that below, so that I know that you guys can do that easily. So let's first of all look at how we're going to calculate. So they wanted us to get, or rather to determine, the measures of central tendency in this case. So I had kind of added them there. Can you see I've taken my mean? Or maybe let me just clear that so that you'll see how I did that. Of course, we said, all right, for the mean, what I'm simply going to do is to say my mean, that's going to be the sum of my individual data, okay, divided by the number of data sets that I have. So in this case, I'm going to say 43 plus 50 plus 55 plus another 55 plus 58. I'm going to show you later when we do another video on how to do this easily using the stat function, plus 62. The other one is 65 plus 70 and 85. Okay, and I get a number 603. So remember, how many data sets do I have in this case? I've got 10, so I'll divide that by 10, which gives us a mean of 60.3. So that is our mean, right? And then they wanted us to get the mode. Remember, what did we say the mode is in this case? So that's going to be A, that's B. So the mode, remember, that's the number that appears the most. Okay, so in this case, the number that appears the most here, obviously, I can see it's 55. Okay, so it means that our mode is 55. And then actually, all of those are A, right? And then the last one, so the mean, the mode, the median. So that is the number that divides our data into two equal parts, right? So I want you to note, because we've got an even data set in this case, what are we going to do? Which one is the middlemost number? Okay, you'll see that we've got 1, 2, 3, 4, 5, but we've got another 1, 2, 3, 4, 5 on the side. So what do? We need to find a number that would cut this data into two. And so what we do, because we've got an even data, So those two numbers in this case are the ones that are in the middle, right? So what I'm going to do is that I'm going to take, okay, if I'm going to, let's call this, this is x5 and x6, right? So I'm going to take those numbers, add them up. So that's going to be x5 plus x6 divided by 2. Okay, so all you simply do, okay, in your calculator, let's clear that. So this is simply going to be 58 plus 60, all right, and we divide that by 2, and obviously that gives us 59. So it means that our median is 59. Okay, right, now the second part of it, they said to us we need to now find out what is the range. Now please, I want you to note, when we're calculating the range, in this case, we are simply taking the minimum value, or rather, let me say the maximum value. We subtract it from the minimum value. We've already grouped our data into an ascending order, so that's going to be 85 minus 43. So this gives us 85 minus 43, right? So in this case, as I said, when we take the range, these are what we call the measures of dispersion, but we'll come to that when we talk about variance and standard deviation. So we take 85 and we subtract 43. In this case, this gives us 42. So that's our range, right? And then we were asked to calculate. Okay, let's go right to the top again. So they wanted us to find out the interquartile range. Now I want you to note in this case, so we've already found our median. Now I want you to note, what is that median? Okay, let me just use a different color here. So what is that median? Median is our Q2 value, right? So remember that when we find so we know our Q2 value, divided that data into two sets, and we said that Q2 value was 59, right? Sorry for making that mess there. Right, now do you see that I've got two halves in this case? So what is our Q1? Notice in this case, what is half of this? Okay, what's the middle value? So I've got 5 pieces of data. So in this case, the one that is in the middle there of the first half, all right, in this case, that's going to be my, 55. And so that value there is Q1. So there's my Q1 value, which is 55. And then my Q3, the one that's in the middle of this. Okay, and by the way, again, if we had data that was even, okay, what we'd simply do is exactly what we did to find Q2. You just add the two values that are in the middle and divide them by 2. So in this case, we only had one, which is 65. So that value there is going to be our Q3. So in this case, it simply means that to find so we're looking for the interquartile range. And again, as I did say that these are sort of measures of dispersion, right? So what we are simply going to do is to calculate those values. They kind of tell us something about what is happening in our data set. Okay, right. Now, quickly, for IQR value, we just simply say interquartile range is Q3 minus Q1. Okay, so our Q3 value, remember, we said that was 65. Our Q1 is 55. So that's 65 minus 55. Okay, and in this case, that will give us 10. That is our interquartile range. And as I did say, when you take the interquartile range, because the range is not such a good measure, of dispersion. So the interquartile range is actually better, because what it does is that you take half of your data set and just measure the dispersion from there. I don't want to say too much, and that's why we are at a later stage going to look at the standard deviation and the variance. Okay, right, now let's go and continue. And then now they said to us we need to now draw the box and whisker plot. Now remember, when you draw the box and whisker plot, what you're going to do is you must always sort of calibrate your okay, I'm going to try and draw a straight line there, your number line. Draw it such that obviously you make sure that the spaces are sort of equal. So let's choose a scale that we're going to use. Can see we start from, our group is from 43 to 85. When I start from 40 and I'm going to increase in fives, right? I think that's going to work. So if we say that's 40, so that will be 45, that's 50, that's 55, that's 60, that's 65, that's 70, that's 75, that's 80, that's 85. Yeah, I don't think I need to go any further. Right, and then let's start with our first. Okay, so our first value there, right? We start with the minimum value, and our minimum value was at 43. So let's say that's 43 over there. Okay, and then our maximum value was at 85. So I'm going to just put, okay, nothing wrong if you decide to put a line there, by the way. And then we also had our Q1 value, right? Remember that Q1 was at 55. So I'm going to put Q1 over there. And I've got my Q3 value, which was at 65. So I'm going to put it there. Of course, please try and make it as neat as possible. Okay, and then I also had my Q2. You remember, we found our median, and our median was 59. So it is somewhere there. Okay, so which completes in a sense our box, right? So there we go, and all we simply do is just try to do that. Okay, right, now then we look at so there is our box and whisker plot. So remember, this would be Q1, this would be Q3, that would be Q2, or which is the median, and in this case this would be your minimum value, and this would be your maximum value, right? Okay, and finally they said we need to comment on the skewness of this data, right? Now remember, we said for you to measure or to look at the skewness, of course if you look at this, it almost looks like your data skewed to the right in this case, right? So what you do is that you are always going to say, well, look, we take the mean and we subtract it from the median. Okay, right, so in this case, what do we have? Our mean value was 60.3, if I remember correctly, 60.3, and we subtracted from our median, which was 59. And what do you notice? It's exactly what we thought. We get a value of positive 1.3, right? So that's going to be 1.3. Okay, and in this case it's a positive value. So what does that tell you, right? So please remember that when we've got a positive value, so it simply tells us in this case, just exactly as we said, that it is skewed towards the right. So if you remember what we had said there, let's go back to our notes, right? We spoke about when the mean, right, mean minus the median is greater than 0. So it means that our data is positively skewed, or you can say it's skewed to the right. And I mean, you can already see that you've got a longer whisker on the right hand side. So we say that our data is positively skewed. Okay, so it is positively skewed, or you can say it is skewed to the right. Ladies and gents, I hope that makes sense. All right, so let's take this quick question for our last example. So they say for the data below, draw the box and whisker diagram. Okay, so again, as I did say, that we are going to always arrange our data in ascending order first. So C will have a 9 there, we'll have 11, we'll have another 11, we will have 13, I think. We'll have 14, and I'll have 18, and then 22. Okay, so of course our minimum value, that's 9, our maximum is 22. So first of all, let's determine our median. Okay, so our median, all right, that's going to be the middlemost value. Yeah, let's just try and write that properly. So our median in this case will be equals to, now in this case our middlemost value, you can see that's the value that divides our data into two equal parts. So it means that our median is 13. If you wanted to get the mode here, okay, I know we're not going to use that to draw the box and whisker plot, but our mode is 11. That's the number that appears the most. And of course, if you wanted to find out what the mean is, of course, what you're going to do is just take all of those values, add them up, and divide them by the number of 1, 2, 3, 4, 5, 6, 7. So that's data set. So you're going to add 9 plus 11 plus 11 plus 14 plus 18 plus 22. And you're going to divide that by the number of data sets that you've got, in this case, which is going to be 7, right? And then you'll get the mean. Of course, I'm not going to do that. I just want to rush to the box and whisker plot. And then we have to identify, in this case, what quartile 1 is. Now, of course, given that we've got our median, which is quartile 2, okay, so which divides, of course, our data into 50%. Okay, so in this case, our quartile 1, you'll see that the data, or rather the value that's right in the middle of our upper quartile, that's going to be 11. Okay, and of course, sorry, our lower quartile rather, and then our upper, or rather, let me rather say our upper half in this case. So the middlemost value, sorry, on this part is going to be 18. So that's going to be Q3. So that's our Q3 value, and that's our Q1 value. If you wanted to find the range, just keep in mind, and I'm just showing you this, not that we need it for the box and whisker plot. Our range in this case would be the maximum value minus the minimum. In this case, that would be 22 minus 9. Okay, and in this case, that would be 13. Right, and then if you wanted to also find our interquartile range, all you're going to do is take the Q3 value minus Q1 value, right, and that's going to give you the interquartile range. Now, I want to quickly rush to the box and whisker plot in this case. So we said the minimum value is 9 and the highest value is 22. So I don't know what we can, okay, maybe actually it wouldn't be that bad an idea. So that's 9. We can use 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, and 22. Okay, so it's 15, 16, 17, 18, 19, 20, and 22. Okay, right, so minimum value, we said that was at 9. So there's a maximum value is at 22. Okay, and then once again, we said we wanted our quartile 1, which was at 11. So there it is there. Okay, and our quartile 3 is at 18. Okay, so there it is there. And then we've got our Q2, which is at 13. So there it is there. So that's our box. Okay, and of course you can extend it to the whiskers over there. Right, and in this case, that would be your box and whisker plot, right? So that would be your Q1, that would be your Q3, that would be your Q2, that would be your minimum value, and that would be your maximum value. Right, and of course you can comment on the skewness of the data. In this case, I didn't calculate the mean, but remember, all you simply say is that you take the mean minus the median, and of course you can comment on the skewness. Okay, ladies and gents, I think I want to leave it there. All right, so after our shaky start in statistics, I hope that you've enjoyed the lesson and that you are able to follow on. So what we'll be doing next time is that we'll be talking about, the measures of dispersion when it comes to statistics, variance, and your standard deviation. And, of course, we're going to be continuing with the ogives or ogives, whatever you want to call it in this case, and we'll continue with statistics. All right, so please don't forget to hit that subscribe button if you haven't already. And of course, for those of you who need assistance, you can always get in touch with us, and our email address is info@mlungisinkosi.co.za. and do look out, we are going to be launching a website very soon. Hey, I'm excited about that. Otherwise, I'll see you guys again next time. Sharp sharp.